Good morning and welcome to our second Build Up webinar organized by the Smart Build for EU project. My name is Karine Lafouin-Loire. I work for Doel Innovation and I will be moderating this webinar today. So today we welcome 9 EU-funded projects, all related to smart buildings, but all with very different focuses and state of progress. They will have a few minutes to present you their project, which is a very challenging exercise, but we'll have some time at the end of the session to answer the questions you may have. Before we start, I will shortly introduce Build Up. So Build Up is a European collaborative platform, always updated, and a key resource on the topic of energy efficiency in buildings. You can register and become a member of a Build Up community to then submit content as news, events, publication, or cases. We invite you to navigate the portal. At the Learn section, you will be able to find the podcast to the past webinars. And at the end of this webinar, the recording and the whole presentation in PDF will be available here. Today's webinar is the second of a series of 5 workshops to be organized in the next 2 years. The aim of these workshops is to share best practices and lessons learned with a community of projects and beyond that with the Smart Building Innovation community. The results and innovation presented will also be key inputs to the work of the task forces that have been launched by Smart Build for EU. Our next workshop is likely to take place as a Sustainable Places conference at the end of September. So please get in touch with us if you would like to present your innovation or project there. And I now would like to welcome our panelists who will present 9 very interesting projects which cover a variety of topics: energy efficient renovation and technologies, energy performance certificates, behavioral changes, demand response, big data, digital twins, and much more. We'll start with the projects that are close to completion, which will highlight their lessons learned, and then we'll move on to projects that recently started. And before we start with our pitch session, Alexis David, our project coordinator, will quickly present Smart Build for EU.
Right. Good morning, everybody. Thank you, Karine, for the introduction. My name is Alexis David. I work at the ECTP, the European Construction Technology Platform in Brussels, and we are indeed coordinating this Smart Build for EU project, which started last October. So let me pass the slides. Right. Yeah, it's not working there. Right. So the main objectives of this project are summarized here with this brief slide. Our global idea is to consolidate and support the innovation ecosystem in the vast smart building value chain. So we want to create and to structure what we have called as big smart building innovation community that would gather all the European project, the European stakeholders that are working on smart building, smart technologies, in order to reference who are the key innovators, to promote the key innovations, to know about the last developments, and to learn from each other. This brings us, once this community is created, and it is already created actually, we will launch collaborative work in order to break silos, to share information again, but also to identify all the barriers, the opportunities, and best practices that have to be tackled before enabling the further uptake of smart buildings and smart technologies. So for that, we have created what we have called task forces, which I will briefly introduce later on. And all the work we are going to perform in this Smart Build for EU project, together with all the people we are going to welcome around the table, will enable us to create a strategic research and innovation agenda that will be shared, of course, with the European Commission, with member states, and with the vast community. So as first to feed the design of the future, Horizon Europe calls on smart buildings to draw recommendations to policymakers, and again to increase the knowledge about smart buildings, smart technologies, and what they can bring to people and to households. And all this in parallel will enable to support the deployment of the SRI, the Smart Readiness Indicator, through the development and testing of some tools, of some modelings in order to provide further indicators in the smart readiness indicator. Next slide. Yeah, so this slide represents very briefly the main activities following what I was just saying. We have the first activity that consists in mapping and consolidating this big smart building innovation community, bringing people together, identifying who does what, and so on. Once this is done, we have organized task forces, group of people that will discuss during periods of 6 months a focus point which has to be tackled in the frame of smart buildings for its future development. Also some workshops, also the promotion of success stories, interesting activities that all the community should learn about. The third activity, well, that is more the more technical one of the project, consisting in, as I was saying, developing some co-benefit indicators in addition to the SRI. So the SRI is a smart readiness indicator, which is a common European scheme for rating the smart readiness of buildings. It helps to raise awareness, to motivate consumers and developers to adopt smart technologies in their buildings. So we are developing some co-benefit indicators in addition to the SRI indicators. We are testing some modelings in buildings in order to assess what smart technologies can bring to people, can bring to households, not only in terms of energy savings or money, but also in terms of comfort, of health, and so on. With those three first activities, we reach the fourth one, which is this research and innovation roadmap, the SRIA, and policy recommendations. We'll summarize that in a big document that we'll share with the vast community. And of course, we have some communication and dissemination activities. So I just wanted to give you a couple of examples of what we are doing. So the current webinar is, of course, one of our activities. We promote what is being done in other projects, and we learn, we get to know other people. There will be other workshops with the same context as Karine was saying, and we have workshops focusing on the SRI, how to train people on taking the SRI and knowing more about it. And we have done already one brochure. There will be more brochure of this kind. You see a couple of pictures on the bottom of the screen, which promotes projects that are working in the field of smart buildings. In the first version, we had 46 projects. We will reach probably about 100 projects in the next edition within a few months. If you want to join it, if you would like to promote your activities, your project, please click on the link and you will be put in contact with us directly. I was mentioning a few times the task forces. So I'm not going to go through this big table here. It's just to indicate you that we have identified, of course, not only us, the consortium, the project partners, but with already the community and our expert board, we have identified 4 main topics for the task forces: interaction with users, efficient building operation, interactions with the external environment, and cross-cutting issues, all of them subdivided into 3 topics. That is a total of 12 topics that we are tackling. Of course, all those topics are available on our website, and you can have a deeper look at them and better understanding, of course. The concept of those task forces is always to define a scope of investigation, what are the challenges, trends, and problems, describe the state of the art, various solutions, good practices, and so on, and possibly in the end to draft recommendations. All this lasts for 6 months. During 4 months, we discuss, we have different iterations. We have a green paper that is open to consultation from the vast smart building innovation community and some other stakeholders. So if you would like to be reached in those open consultations, please register to the SBIC. And we end up with white papers, a total of white papers that will, of course, feed this strategic roadmap I was referring to before. For your information, the first open consultation on all the topic A's will be launched very soon, July, if I'm not wrong. So again, if you would like to participate in that, register to the SBIC. And have a look on our website at the topics B. If you have suggestions, well, recommendations on how to tackle them and so on, they will be launched in September, October, most probably at the Sustainable Places 2021 conference, as Karine was saying. That is it for me. If you want to get in touch with us, you have here a couple of email addresses. There is our website and, of course, the social media. Thank you.
Thanks, Alexis. And I now would like to ask Maurizio Zaglio from Sunamp to present Heat for Cool. Maurizio, the floor is yours.
Thank you very much. Hi, everybody. Let me start by thanking the organizers for inviting us to present this project today. And I'm really glad that I can represent quite a large consortium of partners, as you can see here at the bottom, that have worked on this project over the past few years. Heat4Cool, just is a snapshot. I will share more details later, but it was focusing on the grid flexibility and storage and penetration of renewables into the space heating, cooling and hot water services of residential applications. Of course, we were aiming at minimizing the fuel bills for the tenants while maintaining or increasing the comfort in this building, saving energy. Of course, it was a priority for the project, and at the same times facilitating the managing of the systems and their maintenance and fault predictions. The consortium was very comprehensive. It included hardware suppliers, it included universities, it included consultancies. And I think it was, of course, the variety of these of the partners was key to achieve a successful project at the end. The project started in 2016 and it has just finished recently. Some activities are still continuing under an agreement between some partners. For example, the trial sites are still running. The project objectives, we try to summarize them here, and it was mainly to develop, integrate and demonstrate an easy to install, energy efficient, cost effective heating and cooling solution for retrofitting application. So here we're focusing on existing buildings in the European scenario. Achieving 20 to 30% of energy savings compared to the pre-retrofitting systems, a payback period of about or less than 10 years, to also give a good indication about the exploitability of the results. Demonstrate the replicability potential at residential building and the district level as well, and to identify target groups in the market interested in integrated heating and cooling technologies, to develop a business model that can be used for the commercialization of the solutions, and of course to support the EU energy efficiency policies and promote nearly zero energy buildings. I've tried to summarize here the main phases of the project from start to end. In phase one, we started to focus on the retrofitting design tools. We were analyzing the European building stock and collecting or setting up the data set for the retrofitting toolkit itself. We started to develop the optimization algorithm for the solution set provided by the hardware developer and suppliers, and the user interface, started to work on the design of the user interface. This tool is available on the Heat4Cool webpage for everybody to try. In phase two, I've collected here the list of technologies that were developed during the project. I will go into a little bit more details in the later slides, but they are a solar thermal assisted circular heat pump, an electric heat pump with phase change material, hot and cold storage, a wastewater heat recovery system at district heating level, and assign building energy manager systems. And I have a slide for each one of these later. Phase three, following the development, focus on the integration of optimization of such technologies, including a development of models and the application of such models to different case studies. Finally, phase four, we went into real buildings to test these technologies, to validate the models, and of course, data collection and monitoring has been and still is a very important, a key part of the project. A little more details about the solutions. I represent this company, SANAP, and in this framework, we have developed and refine two technologies. One on the left are the heat batteries, very compact hot and cold storage system, thermal storage systems. They're based on phase change materials, also developed and manufactured at Sanamp. Big key benefits are a 50% or more reduction in occupied volume compared to state-of-the-art and traditional water tanks. This is also depicted in the picture, as well as more 50% of more reduction in heat losses. So also efficiency is a key benefit of this technology. They are modular and scalable, and they are dual ported. They contain, dual ported heat exchanger, meaning that they can be charged and discharged at the same times, so maximizing the flexibility of the technology. And we have reached, with this design of heat batteries, we have reached commercial phase product, and you can find more information on our webpage. At the same time, in parallel, in collaboration with other partners, we have integrated this compact
Maurizio, I don't know if it's only me, but I cannot hear you anymore.
Sorry, I must have pressed the wrong button. Is it? Am
You're
I back now?
Yes.
Sorry. I was saying, in parallel, we have also developed with partners a heat pump that includes the phase change material storage developed also during the project. This is a reversible heat pump able to provide heating and cooling and hot water at different sizes. We have tested two different sizes during the project, one at 15 and one at 40 kilowatt. As I say, you see that in the enclosure of itself of the heat pump, we have the storage, and the ability to use DC power is also included in the technology. Moving forward, sorry, too much. We also have the desorption heat pump developed by Fahrenheit. They have developed two kinds, one including zeolite coating and one silicon coating. Of course, using solar thermal as an input for the cooling and the water as a refrigerant. I'm not expert in this technology, but I will be glad to refer you to the Fahrenheit team if you have more questions. Thermovat, in Hungary, they have developed a wastewater heat recovery system that they have installed in the sewage system of the city in order to provide heating and cooling at a district, to a few buildings connected to this district thermal energy network. And again, I would be more than happy to put you in contact directly with them for more questions related to this. Watt and Volt has focused on a self-correcting intelligent building energy management system that has been trialed in the trial sites as well, which is the brain connecting the various energy devices, as well as the devices delivering the thermal energies to each apartment or to the building involved in the trials. And more importantly, all of this has fed information to the building retrofitting design planner tool, a very versatile system that can take or compare existing scenarios for heating, cooling, and hot water to alternatives, including the developed technologies, and can provide a significant amount of information about the energy consumption, energy reduction, usage of renewable or still non-renewable energy sources, and comfort level of the apartment. At the same time, it can also provide modeling and simulation month by month based on real climate data of the, again, comparison in, for example, energy consumptions of current system in existing building and alternative system that might be applied in the retrofitting of such building. And this is my last slide. As I said, we have trialed this technology in multiple buildings. There was a pre-trial in Bilbao with Tecnalia, and then we have installed the various technologies in different countries, so different climates at different sizes of building, from a 3-floor, 4-apartment building with the heat pump to a district heating network with 3 buildings connected to our technologies. Very happy, as I say, to share more information with you, and I look forward to your questions after the presentation of the other teams. Thank you very much. Oh, sorry, the lesson learned, if I can have 10 seconds. I think this was important, especially for the project that just started. Let me just say that let's focus on the big pictures, not only on finishing the project. So let's always keep in mind that you want to use the solution globally. And therefore, I think it's very important that all the partners are aligned to achieve this target of making the world a better place through the use of these solutions. Thank you very much.
Many thanks, Maurizio. Very interesting lessons learned. Michele Vavallo from Solintel will now present Renozeb.
Yes, thank you very much. Good afternoon. Thank you, the organization, for giving us the opportunity to walk you through the Renozeb project, accelerating energy renovation solution for zero energy building and neighborhood. I'm the coordinator of this project and I work for Solintel. It's a project that started in October 2017 and will finish in September 2021. So of course, in Horizon 2020 project, and you have the web page, renozeb.eu. You can go there, register and receive the newsletter. You can also study the web and get acquainted better about what we've done and what we're going to do, because I have just 8 minutes today, very difficult to do it in this time. Yes, the most important impact we are looking for in this project is getting 16% cost reduction during the renovation, deep renovation in residential sector, 60% energy consumption reduction, 65% renovation process time reduction. Our solution to get these figures have been working for one side in the multifunctional modular plug and play, easy to install, cheap, fast installing, easy to transport, pre-manufactured, customizable and standardizable also units, facade system in standardized. The standardizable is for trying to be installed in any kind of residential building all over Europe, different climate and different also situation. We went through tests and we succeeded. And from the other hand, we have also worked into an ND collaborative environment platform, in which there are different tools. Well, we are going to have a look at of some of them, and in which all the stakeholders involved into the renovation process could stay there and register and work together in all the different steps and phases of the renovation, from design, planning, logistic, manufacturing, and also the last phases in the maintenance as well. Always without forgetting the property value as a main trigger for the renovation market. This is very important. Now let's start introducing what is the hardware part of the project. These are some sketch of the 4 units we have created, and we are going to demonstrate and validate in real pilot. So as you can see here, they are easy to be installed because they are clicking in fixing mechanism, and we have opaque windows, photovoltaic solar thermal collector unit. As an example, you have here pictures taken from the company Focchi that manufactured them. You have the opaque solution. For example, in this case, we have ceramic, different color, and also wood or wood plastic composite as well. Still, you can increase the catalog and you can pick whatever you want to get different aesthetic to the building, but also you can change the aesthetic to the building after several years during its lifetime, for example. And on the right side here, you can see the mock-up of all the components we put in the just in a picture to let just for showing. And this is, for example, this is what is the platform and the platform. This platform has been created by Tecnalia. There are different tools that engines the platform for the decision taking. These tools are, for example, the IFC viewers, the BIMs, the Smart Logistic Infrastructure Management tool. We will see also other one, but there are others as well. No time for introducing to you. And in this case, what you do is create a project. You can talk between stakeholders, define KPIs, targets, scenarios, and also evaluate the scenario according to the KPIs you have created to define and decide which is the best retrofit work you can put in your building, like an example. So here you can see, for example, the first the option to simulate and digitalize the building through the point cloud you can get by laser scan or droning, and you can also georeference it for harvesting geothermal and water data for the estimation. Here you can see the BIM models of the real building we have in the pilots that I will introduce to you later on. We have created also a system, a QR system coding that could that goes with the components and also the units. And this QR code could be used for information sharing during the logistic, but also during the manufacture, the installation of the solution in the field. For example, for contractors. There are video supporting the installation or any other technical fiche that support also the understanding of what has to be done, the steps and stuff like that, to help and easy the life of the contractors during the manufacturing, during the installation of them. This is an example of the knowledge-based tool, and in this case, we have water data of some spot of Europe, for example, and we can extract, of course, also cooling and heating degree days to be used for the calculation of the thermal improvement of the simulated thermal improvement of the building through and thanks to Renault ZEB tools. This is a case in which you take the beam of the building, you can play putting and like the Lego, clicking on the tools, and you can put Renault ZEB facade there, the different units you have seen before. For one side, you can understand which is the outfit and the aspect of the building at the end of the retrofitting, just to have an idea. But also you can simulate which is the improvement in terms of energy behavior of the building as well, and give you an idea about the improvement you can get, and making your estimation related to, for example, money. Very shortly, I would like to introduce the two building in Durango and north of Spain, and it's a building from 60. You see here the real picture, the simulation by our tool, the real building after the retrofitting. We would like to get 80% of improvement of thermal behavior. And here you have the Ball one in Estonia, is a private building. The other one is a private public. This is a private. Is a residential public building, and this one is a private residential building. You see again the simulation in white. They after decide to stick with the same color, and in this case we would like to get also 53% of improvement. Lesson learned very briefly for us is the pilot deployment, because we from theory to practice always there are issues there. There are unforeseen, there are delays, there are public rules and regulations to follow, different change in policy issues, and of course, it entails to always an extra budget to pursue and solve this problem. Validation process is on the way. The two building will be finalized in July, so the post-validation process will be started from July on. And these are the partners involved into the project, and you have here my contact if you would like to get in contact with me for any doubt. Please remember that you can register yourself into the webpage for follow up what is going to come. That is the most interesting part. That is the validation. Thank you very much.
Many thanks, Michele. And the e-teacher will now be presented by Carmina Boccanegra from CEMOSA.
Good morning, everyone. I just would like to first thank you for the opportunity of presenting e-teacher at this event. My name is Carmina, and I work in CEMOSA, who is coordinating this project since October 2017 and is finishing within this month. And the aim of this project is to help end users to save energy within the buildings and also improve their well-being, the thermal comfort, indoor air quality through enabling behavioral change. The main challenges of this project as e-teacher solutions are based on ICT tools. They require integration and interoperability with the building automatic control system and also the building energy management system, and this is a very complex task. Also, there are many types of buildings, and within the project, we have a demonstration in pilots within the residential buildings, offices, healthcare centers, and also schools, both public and private. And on top of that, the solution has to be cost effective. On the other hand, as we have many types of buildings, we also have many types of users, and we have teachers, we have facility managers, people that live at their homes, and they have different understandings of energy consumption. They are also for different countries, so this is another challenge. And finally, recommendations to save energy may compromise at high comfort levels, so we need to optimize the recommendations to save energy, but do not sacrifice the comfort. Here, there is a picture of all the different pilot buildings I mentioned before, and you can also see the different monitoring systems we have implemented within the project to give you an idea of this complexity. So a teacher solution is located within between the building performance and the user behavior. So on one side, we have developed the BACS add-ons, where we have developed the communication interface to communicate with the monitoring system of the buildings. So we gather the data from the sensors, we do the data processing, and with this data, we have developed an algorithm, which is the what if analysis, and we estimate the energy savings that we can have depending on the actions we take. And with this analysis, we go on the other side, which is the end user solution, and we give the users tailored advice, which are specific to their conditions, depending on their behavior, the indoor conditions, the outdoor conditions. And we give them information about how they are using the energy. We also motivate them with gamification. And with all this information, users can take informed decisions. And also they can give us feedback about how they are feeling in their buildings, if they're comfortable with the indoor conditions or not. As a result of the projects, we have, in the social side, we have developed the energy behavior change framework. On the technical side, we have developed the e-teacher toolbox, which is the app and all the tools that are behind it for it to work. And we have also developed the integration methodology, which are the steps that are needed to implement e-teacher in the different type of buildings. As an example of the results we are gathering, here I show some results from the healthcare center in Villafranca. And you can see we have measured different type of consumption, lighting, HVAC, appliances, and we have this information before and after e-teacher. And we also have information on the behavior change we want to achieve. So we are gathering data on whether the people are turning off the lights when they leave the room, or they are turning off the appliances at the end of the day. And we are going to analyze and compare all this data before and after e-teacher to see how effective the solution is. And we will publish this, all these analyses at the end of the project. So the added value to the society, as I mentioned, first is the customized energy saving recommendations based on real-time data. Also, the methodology that we have developed, including behavior change concept when we design the monitoring system and the installation of the sensors in the buildings. Also, this approach for continuous monitoring and data analysis can help to detect inefficiencies quickly in order to find solutions as soon as possible. And also, it can improve the actual purpose of energy audits, not only focusing on energy savings, but also in comfort and indoor air quality. Another added value is the understanding of behaviors of different users, so we can develop an attractive solution for all of them. And finally, we have developed a simple to use and clear fund tool. So as lesson learned, we have faced a lot of issues during the project. And here I just mentioned some of the lessons learned, which first of all is the reliability of the sensors and the data quality is an issue. And this needs to be considered and addressed from the very beginning of the project. Also, as I mentioned before, the integration and the interoperability is a complex task. So we need to pay attention to the data transmission, the division of tasks, and also the storage of the data. On the user side, we have also privacy issues, especially in residential buildings. So we need to motivate users, inform them correctly on how the data is going to be used, what is the purpose of the project, in order for them to engage and be confident with the project. And finally, we are working with a lot of amounts of data. So we need to really think of how to deliver useful information to the user and not overwhelm them with big amounts of data. So that's all for my part, and I'll be happy to answer any questions about the project at the end of the session. Thank you.
Many thanks, Carmina. And let me remind the audience that you can put your questions in the chat section and we will then address them at the end. Our next speaker is Jia Lennart from R2M Solution presenting the TABED project.
Hello, thanks, Karine. Yeah, nobody really knows. It's TABED, and it stands for Towards Buildings Ready for Demand Response. Thanks, Karine, and thanks Build Up and Smart Build for EU for inviting us. So a quick overview of the project. We just finished this past month, 2 months ago, and had our review yesterday, in fact, which went quite well. And it's a 3.5-year project. The half is for the COVID extension, which many of us probably got. We have, let's see, 1, 2, 3, 4, 5, 6, 7 partners, 2 Schneiders. We have R2M Italy, which I represent, Schneider France and Schneider Italy, which are both demo site owners, CSEM, which is the Swiss Technology Institute, and NG Tractebel, representing the grid side, Cardiff and CEA as well as partners. So if I can go to the next slide here. Yeah, good. So the 3 main research pillars here, this is a bit of a qualification. So the main goals were to focus on these 3 aspects, but we wanted to equip any building type that had a building management system or BMS to be able to respond to demand response signals and utilize their existing energy flexibility. The key aspect of the project is focused on interoperability. So regardless of communication protocols being used, we developed something called the BMS extender, the BMS-E, which is able to adapt to existing BMSs and enable them to participate in demand response schemes, enabling higher levels of functionality, but also maintaining comfort of the users was a big part of it. So from that qualification, oops, wrong way, here is a bit of a quantification of those main objectives. So here is a picture, an image of the BMS extender in the middle. It's the hardware, but there's also a graphical user interface. And then in the blue boxes surrounding it are the 4 main objectives, or scientific and technological objectives. And going around quickly through them, on the top is the interoperability. As I mentioned, we had the goal to connect with 90% of devices found in a building. We actually surpassed that and reached 100% of the 3 pilot sites, which I'll explain in a bit. You know, starting with the most common protocols, some of them are listed here, but a key goal was to be able to adapt to new protocols being developed to hopefully avoid vendor lock-in of new devices. And then moving down in a clockwise fashion, objective 2 was about the flexibility of devices. We wanted to improve demand response capabilities by 2 times. We noticed that when there's existing flexible assets in a building, there becomes more opportunity for cost savings. So if there's storage and PV, obviously you can capitalize more using the BMS extender. Objective 3 is about the communication between the components of the BMS extender. So each of the partners were component owners. So just as an example, Cardiff University developed a environmental forecasting device. NG Tractebel developed a demand response automated server for responding to grid signals. CEA developed their optimization tool with a multi-agent system, which is an artificial intelligence algorithm. And they all communicated together in order to give the end user the information to utilize their flexibility. And then the 4th objective is about the demonstrations at the 3 test sites. So we wanted to focus on cost savings, and we reached 33%, up to 33% of cost savings, as well as showing the increase of self-consumption using on-site PV up to 51%. So here is, excuse me, yep, okay, one too many. Yeah, so just basically the same thing. This is how we responded to the challenges of the call. So I won't go through everything, but we increased renewables penetration by 25%, was able to demonstrate grid investment deferments. And then the 4th one here is key. We wanted to reach TRL 7 to be able to show that within 5 years, it can be a plug and play solution at TRL 9. And then the 5th one is just showing how by receiving this information, the building occupants move from passive to active consumers. So just 2 more slides here. This is the pilot scheme. So we had 2 residential buildings, Smart House in Cardiff, UK, Smart Home in Bergamo, Italy, and then a large commercial industrial building in Grenoble, France. And basically on the right here are the use cases. I won't go through them, but feel free to refer to the website for more details. And then finally here, oops. Yeah, so the main lessons learned are we broken down to policy, certification systems, and standard bodies. So just quickly going through them, for policies, we see that demand response is not profitable, but is increasing in policies instruments. And the DSOs are less interested at building level, more district scale. On the middle here, we've noticed that the smart readiness indicator, which we deployed at 2 of the sites, there should be a minimum score for buildings and a more higher emphasis on demand response in these certification programs. And the device labeling of smartness is a hot topic for the commission and key for interoperability, which was again part of the main focus of the project. And finally, on the right here are the standards. Some are proposed but not always implemented, so the harmonization of those standards across devices will be key, and a platform for testing the interoperability, as well as common communication protocols for demand response between grid and buildings. And that's it for TBD. Always happy to answer questions, and thanks for your attention.
Thank you so much, Ziad. And our next speaker is Ander Romero from Tecnalia, presenting Holister.
Hello, good morning. May you hear me? Okay, thank you, Karin, and thanks, Smart Build for EU project for the opportunity to share the results of Holister. Holister is a 3.5 months project that has been running up to March 2021, and is also dealing with the integration of demand response into the energy markets. We have 3 partners on board on this challenging project, and well, I'll go quickly through the project objectives. As we all know, mainly the demand response currently schemes are gaining a lot of relevance in the energy markets in Europe. And well, the challenge here is, and the challenge that the project is addressing is how to introduce at the end residential and small tertiary buildings within this market. However, there is still some relevant key enablers that need to be satisfied, which are basically the consumer empowerment and the interoperability, as Sia mentioned before, which is very relevant in this kind of projects, and also introduce new business models. So for that, the project have 7 objectives. One is dealing with the introduction of these consumers as active players within the demand response schemes by playing a human-centric demand response program. This is basically implicit ones. Also to enhance somehow the current system and legacy equipment of BEMS and smart home systems, integrating them with ICT and predictive maintenance solutions. Also very important, the objective of provide with an open standards based solution. We'll see later on the lesson learned also the importance of providing these standardization schemes for interoperability improvement. And obviously also in the explicit demand response side of the programs, introduce grid reliability through aggregate flexibility using. In the business side, let's say that addressing one of the 3 key enablers, introduce some suitable business models that allow energy utilities, aggregators, and facility managers the deployment of this kind of schemes. We have validated, as we'll see later on, these solutions in real life environments in order to acquire at the end this consumer engagement needed for the deployment of demand response schemes. And finally, we have carried out an intense dissemination and knowledge transfer that can be further seen in the project web page, where all the public deliverables with extended information can be going quickly through the solution and the key results that we have get during the project. Well, we started by providing with what we call a holistic demand response optimization framework that on the one hand allows reducing energy cost at the building or consumer side, while on the other hand allow this integration as contributors to stability of the energy networks. For that, we have included a wide range of mature and proven technologies, namely JACE, DAFI, coming from Honeywell, for example, TNO, but increasing them with fully fledged of tools that have been developed within the project in order to make these solutions attractive for all kinds of stakeholders. For that, the key results are that the solution is able, as we can see in the diagram, it's conformed by three different layers: the visualization one, the analytic ones, and the interoperability and data gathering one. So it allows this solution to integrate or bring together both the energy networks, BEMS, and devices from the whole value chain. It allows also supporting different hybrid demand response schemes, implicit, explicit, even including thermal storage concepts. That allow these end user applications to deploy, let's say, informative billing information, for example, energy management based on human-centric solutions, etc., etc. At the end, these new business models ensure this consumer empowerment by reducing the energy bills at the demand side, while at the other hand allows somehow energy poverty reduction. These have been applied in 4 different pilots in Finland, UK, Greece, and Serbia, where we have implemented several use cases ranging from ventilation systems strategies, flexibility that a portfolio of buildings can provide in terms of thermal storage to the grid. This is the case of Finland. In Serbia, we have developed a user engagement application in order to improve their domestic heating systems efficiency and consumption. In the case of UK, where we have Kiwi as aggregator, well, we use it for validating some explicit demand response and flexibility potential on critical loads schemes. And finally, in Greece, we have also focused on reward-based programs for end users, both in residential and in office buildings. This has been done by approaching through a scale of implementation, where we are starting with smartizing the buildings, following the smart readiness indicator assessment. In the same time as the solutions, analytic solutions were deployed or were developed, they were deployed in the pilots, and well, finally with the delivered pilot impact assessment at the whole building level. And finalization with the lessons learned on this project, which are very relevant also, I think, for upcoming projects, is at the policy level, where it's clear that the demand response market development needs to be fostered. Hopefully, European directives transposition will be increasing this position. Also, the new business models that can be developed within these demand response schemes, like the dynamic virtual power plants, tracking demand elasticity, etc. Increase of the smart buildings and power data research, also mentioning smart readiness indicators, the need for further software platforms, etc. And finalization, the concept of a standardized solution for standardized value chains, which is basic for this the deployment of these solutions, including even aspects as interoperability and blockchain technology that will unlock at the end this business models. So, sorry, I have a delay. This is my presentation.
Many thanks, Ander. And thanks for all the first speakers for this excellent presentation. And let's now give the floor to projects that recently started. And we will begin with EPC recast presented by Olivier Gresloup from CSTB.
Yes, thank you for inviting us to present the EPC recast project, which is a project that is part of a pool of projects working on setting a new generation of EPCs in the EU. So we have at least something like around 10 projects, 10 to 11 projects that started before us, or even that start this year, that work on this new generation of EPCs and a lot of topics to improve them. So I'm coordinator of the project. CSTB is a scientific and research center at the heart of the building sector in France. So we are guiding and supporting stakeholders in the transition of the building sector and the construction sector in relation to the digital, energy and environmental transition. So the project started just it's a new project that started in September last year. It will last a little more than 3 years at the end of 2023. We have a quite comprehensive consortium with partners from 6 countries, with large research centers, universities, energy companies, ESCOs as well, to work on this very interesting topic. And as you can see on the right part of the slide, we are dealing with most topics in the SRI, and I will discuss about that later, because I would like to focus a little bit on how we will test and try to implement the SRI in the project. So first ensuring I can move to the next slide. Yes, it's working well. So maybe just to recap what is an EPC. It's a mandatory tool that has been introduced in the Energy Performance Building Directive at EU scale. So each country has to implement it in a way or another one. The idea is to produce a certificate with a simplified evaluation of the energy performance of building. Either it is based on energy calculation simulations, or it's based on builds and measurements. And the idea is to provide summarized information to building owners and tenants about what is the current performance of their buildings rated on a scale, and then providing renovation recommendations, simplified one for the time being, to improve the building after renovation. And the current consensus at EU scale is that this tool has not been used implemented a lot to move to deep renovation projects, and that the reliability and comparability of working practices of EPC assessors vary a lot from a country to another one, and either at the heart of a given country. So we want to develop a full prototype of cloud system toolbox that will help EPC assessors improve reliability of EPCs through innovative on-site data collection methods, quality check procedures, and measured data and public databases. We want also to improve recommendations about renovation actions in relation with building passports and renovation roadmaps. Moving to the next slide. No, sorry, just the previous one. Yes. So this cloud system will allow to improve the data collection and enrichment of information on-site with connections with smart meters, public database, and on-site scans with new technologies that will allow to generate a BIM model of the building with a smartphone, for instance. And then we will try to ensure data interoperability, input-output links with EPCs, between EPCs, digital logbooks, renovation passports, so that documents that are, for instance, provided in logbooks can be used by EPC assessors to better calibrate their energy simulations for EPCs. And then we want also to improve energy recommendations for renovation through renovation roadmaps implemented directly on the certificate of the EPC, building on work that has been done previously in the Alben project. So we could have recommendations based on better control systems for the building from the information that is provided in the SRI. So you can see at the bottom of this slide that we have tried to better emphasize what could be improved for control systems based on the SRI in the Alben project, and we're going to build on this work in EPC Recast to help owners of residential buildings understand what could be the major improvements of control system in the renovation actions. So as this is a new project, so the next steps are for this year and the 2 next ones. So first we will test our toolbox on 150 pilot dwellings in houses and flats in the 6 pilot countries in the EU. We will implement long-term monitoring in 50% of the pilot dwellings and test the SRI on a given set of these pilots. And we have also planned to define the content of a new certificate, so to work on the template of the certificate and to develop and co-design the indicators and information on this template with stakeholders. So we are going to organize workshops. So if you're interested to participate to these workshops, please contact us. We will set up these workshops in the coming months. So thanks a lot for attending this webinar, and please contact us for more information about the project.
Present metrics.
Hello, good morning. First of all, thank you for giving me the opportunity to present here today Matrix project. I am Pasquale Andriani. I work for Engineering Informatica, and Matrix is part of this topic belonging to big data for buildings. So we are going to take care of several cross-cutting themes around building and energy efficiency. And consortium, you can see all the logos of our partner below. It's quite huge, and it involves several kind of organization. So covering research, SMEs, non-government organization, so taking a wide variety of stakeholders. Let me go very briefly to the project objectives. So we have 7 objectives divided into 3 categories, so scientific, technical, and business ones. And first of all, we are going to develop a reference architecture for AI-based scalable big data management and analytics in smart energy efficiency building. Then we are going to also address semantic and business interoperability as a framework to ensure how to deal with the variety of data, not only big in terms of volume. From the technical point of view, you can see here very briefly which are the main objectives of the technical work packages that are into the project. So first of all, we are going to deliver a data governance layer to facilitate cross-stakeholder data sharing, exchange, and handling. On top of this, we are going to develop a set of trained high-quality machine learning and deep learning models. And finally, we are going to deliver in several forms, you will see later on in next slides, an analytics toolbox to allow SMEs or new developers to build new application, new services by combining using different data and already trained machine learning models. From the business perspective is that we are going to demonstrate these through real life application, and we do have quite huge number of large scale pilot addressing several dimensions, and this will also shown later on. And finally, we are going to provide hopefully to boost use scale data economy and valorization and impact on data, on standardization about using different kind of data. Let me go very briefly to the our target architecture. So from the bottom layer, you can see here that we are going to take care of different and extensive data hubs or open data sources. ranging from energy consumption data, weather or climate data, EPC sources, and so on. And on top of this, we are going to build our, let's say, matrix governance layer that acts as a middleware, as a mediator between data users and data providers. So to ensure governance and interoperability between several kind of formats, anonymization, and so on. On top of this, there is matrix processing layer. Grouping, let me say, a library of reusable AI, machine learning, and deep learning models, and serving these towards to the toolbox, which is the matrix analytics layer. And in the toolbox, there are a variety of tools ranging from visualization and reporting engine, analytics building services that will be exploited to the large-scale pilot, digital building twins. And these are in the forms of software as a service. Then we will provide also something like virtual workbench to address platform as a service modes of delivery. And finally, also infrastructure as a service, so to let external user, third parties install and use the Matrix Toolbox on premise, so in form of containers to be deployed in a private cloud. Finally, just want to say something about yes, pilots and demonstration. We are going to address 11 large-scale pilots supported by 2 testbed and digital building twins across 9 countries. In this picture, just want to say that Matrix pilot approach covers the whole life cycle of the building. So from the product manufacturing to the design, the operation, maintenance, as well as addressing cross-cutting things like policy making and research. And building are considered from different perspectives and scales. So we are going to consider building as an individual element. You can see here on the left side, and then scale up to this district level, city level, regional, national, and European. And in the picture, you can see how all of the 11 pilots address several priorities according to the scale they are placed. And just there is not so much time to explain this, just last things. So you can see that we are addressing different also different teams, cross-cutting things. So performance, design, policy, and funds. So again, to address several kind of objectives and placed on a different scale. Just give me the opportunity to invite you to visit our website and our social channel. And if you would like to know more about the Matrix project, you can think to subscribe and follow the first Matrix stakeholder workshop, which will happen next Tuesday, so on June 22nd.
Thanks, Pasquale. Thanks a lot. And now Phoenix will be presented by Antonio Scarmeta from the University of Murcia.
Hi, good afternoon already. So let me, sorry, go back. So let me present here the initial results and the initial vision that we have with the project Phoenix. Phoenix, as you can see for the name, is a quite long name. It's basically the main focus is to try to develop some kind of plug and play, if you like, a simple mechanism to integrate in this case, legacy equipment in the case of buildings, so that we can improve basically the efficiency and increase the smartness of the existing buildings. As you will see later, we have several areas where we are trying to cover with this approach. You can see basically here the website, and where you can see all the partners that we are involved in this project. So basically, as a general vision, we have, as you can see here, in decreasing order, if you like, or increasing order of complexity, what we want is to first to work on this definition of mechanisms that allow a simple integration, a seamless integration of a domestic appliance, legacy equipment, building system management in a easy way, or simple way, if you like, from the perspective of the end users and the building managers in Shenzhen. So how to integrate existing solutions that already said about equipment, and how they can be integrated in a holistic approach, so that we can manage all the data coming from these devices, manage a data repository, and over it create some kind of new knowledge over this data based on the detection of tendency, patterns, and this kind of element. No? So this is basically linked to the second point, that is to building this knowledge phase, if you like, system that you will see later is a platform that is based on several layers that try to go from the data to the information, and from the information to the knowledge, so that later we can create real new services over the information that we are able, and the knowledge that we are able to generate over the systems. We also want to, and this is connecting with some of the previous projects, the idea is that not only think about the building as such and the individual users, but also think about how this building is connected to others, in the sense to connect it to the grid, and how this interaction could also need to be taken into account in order to provide efficiency on the management of the energy that we have there. And then obviously, and one important point also was mentioned with the previous one, was to have basically to be able to manage in a private way, in a privacy preserving way, all this information that we are able to gather, and how to create new services over it, etc. So basically, just to show you some example of the solution here, is just to be short, is we are creating devices, a small appliance, basically, in that sense, based on connection to the existing legacy system, and in the other side that are able to connect to the internet, so that basically use standard protocols that where we can provide all the data that we have from the different legacy in our platform. No? Here you can see an example of different examples that we are now testing on what we have a proof of concept scenario, where we are integrating solar thermal plants, we are integrating EV charging system, monitoring and air conditioning, heating, ventilation, integration of existing sensor that could be based on city-wave, legacy systems. So all these elements are part of our infrastructure that is able to provide a collection of data of the system. At the end, we want to target a solution that could cope all the scenario, from the occupants to the ESCO and energy retailer, but also the connection to the grid, as I already mentioned, because we understand that in the new ecosystem, we need to take in consideration all these stakeholders, so that they can be part of the play of the game in that sense. Just to finalize here, you can see a little bit basically what is the vision, the integration approach that we are already having. What you have in one side is the platform that actually we are deploying on the proof of concept. Later, we will have this platform, this proof of concept being validated over 5 different pilots, real pilots on 5 different countries. And basically, the idea, as I already mentioned, is to have, and similar to other projects, to be able to manage through the use of ontologies or data models, more than ontology indeed, the information coming from all these different sources, so that we can later be able to make some analysis over the data, over the information, to create new knowledge, and over that knowledge they can be used for the provision of the service in that sense. So where we are now, basically now we are on the finishing the first phase, where we already collect the requirement, we collect the social, technical, etc. We already have made a first deployment of the proof of concept scenario with some of this technology that I already showed you, and now we are in the phase to first validate this with it, and then to test concrete services, either for building occupants, but also to energy utilities and the grid, so that we can, as you already mentioned, try to cope with all the different stakeholders that we have. And that's all from my side. Thanks.
Many thanks, Antonio. And our final speaker is Katerina Valalaki from Hypertech, presenting Cogito.
Hello, good afternoon from my side. Thank you very much for the introduction and the opportunity to have this nice workshop today. So I'm Valalaki Katerina from Hypertech Energy Labs, the project coordinator of Cogito, meaning construction phase digital twin model. We are relatively at a relatively early stage of the project. We are running at the 8th month of the project, and as you can see, our project consortium is composed of a number of partners distributed around EU, ranging from SMEs, universities, research institutes, technology providers, and industrial partners with actual construction sites. Just mention that this project is a bit different in the concept that in the actual sites that we are going to demonstrate and validate, focusing on construction projects. So let's have a look at the Cogito objectives. Cogito aims to digitalize construction phase by providing a construction phase digital twin and supporting services. Utilizing this digitalization, Cogito aims to alleviate construction cost and time overruns, and this in turn can be translated to less embodied energy for the construction tasks involved in a construction project. This is an indirect benefit. However, it is going to be evaluated, assessed, and quantified with appropriate KPIs as part of the Cogito evaluation methodology that is currently being developed. Another objective of Cogito is to reduce construction site accidents and fatalities, which are commonly faced in such construction projects, by providing services for efficient health and safety and workflow management. The overall Cogito toolbox is going to be demonstrated in 2 actual construction sites in Denmark and Spain, while one of the key objectives of the project is to promote interoperability of construction digital twins by utilizing and further enhancing standardized data models like IFC and ontologies. And the last objective, not in the technical side, but more in the market side, is to promote in the various stakeholders the adoption of digitalized solutions like Cogito in real-life environments. This is done through intense communication and dissemination activities that have been planned within the project. Let's have a quick look on the solution that we are developing. Cogito will provide a construction digital twin platform with a number of supporting services. Actually, as planned, data included geometry, resources, cost, and time are linked with data streams coming from IoT equipment employed in the actual construction sites in order to be processed and infer the actual as-built model, the actual progress of the project, and provide a number of services in order for providing health and safety and workflow management, as well as quality control, and provide a number of user-friendly graphical user interfaces and supporting applications to be delivered to the different roles involved in the workforce of a construction project, including project and site managers, health and safety personnel, workers, etc. It is evident that a Cogito solution targets lean construction companies, and it promises to provide cost savings, improved predictability, and workforce productivity while reducing accidents and fatalities on site. Our aim is to structure a mutual and reinforcing incentive in order for providing benefits to all parties involved in the construction project. This is actually the unique value proposition of the Cogito product. To do so, we have designed a user-driven innovation approach based on living labs that have been established in order for enabling co-creation and exploitation of project results and maximize project impacts. We collect actual stakeholder needs and disseminate results, and by utilizing living labs and direct continuous feedback with relevant stakeholders, we accelerate knowledge sharing, we customize the technology and the solution that we are providing in order to create an attractive end product which will cover the desire and the actual needs of stakeholders, and this will help us to create a feasible and realistic go-to-market strategy. To do so, we have two phases for validation and demonstration of our tools. In the pre-validation phase, we are going to test and refine the developed tools. This will be done in an actual infrastructure test lab that is owned by RSRG, an industrial partner of Cogito. And having the tools refined, we are going to validate them on actual construction sites in order also for quantifying the relevant benefits coming from the Cogito solution. The two sites are one in Denmark, and it is relevant with a construction project for the Copenhagen Network Extension construction project, and the other one is in Spain, relevant to the high-speed underground station, which is actually an adaptation of the current railway corridor, and it is undertaken by the other industrial partner of the consortium, Ferrovial. So I would like, before concluding, to invite you to follow us in our social media channels that you can see here, and just to bring to your attention that in the coming month we are going to release 3 reports. Among them is the Cogito evaluation methodology, where we are going to provide the KPIs and the methodology for assessing energy savings in construction phase, along with CO2 emission reduction KPIs and so on. Thank you very much for your attention, and I'm looking forward to your questions.
Thank you, Caterina, and many thanks again to all our panelists. So we still have a few minutes left for some questions. You can enter your questions in the chat section. We also have prepared some. I think there was a rather technical one for the Heat for Cool project for Maurizio, but unfortunately Maurizio had to leave already. So I suggest that I pass on your question to him, and he will answer your question directly. Adriana, if you could maybe provide your contact details to build up or to myself, and I will then transfer you the answer. While we wait for the questions you may have, I wanted to ask one to our panelists. Interoperability has been mentioned a couple of times. So that was my question, how you guarantee that the systems of solutions you have developed or will develop are interoperable with other existing and future installations. Maybe we could start with Zia from the Tabile project, and then I'm sure other panelists will have something to say as well.
Thanks, Corinne. To be honest, I'm not an expert in standards, but I think that the main way to do it is by testing various devices. So within our 3 pilots, we noted that all of the existing devices, including renewable systems, were able to be connected. So I don't have an expert answer on that, but it was the main goal of the project. So please feel free to reach out to me, and I will connect you to the experts that dealt directly with the standards.
Okay, thanks, yeah. Antonio and also maybe Caterina, do you have something to add to this point?
Yep, thanks. Yeah. I mean, I think that one of the issues, for example, that we are trying to take into account in the case of Phoenix is exactly the interoperability at different levels. So I would say one issue is about that's why is the emphasis that we are putting on working on the data models, so that we can really be able to integrate different sources of data in that sense. That in some case are the legacy, but also could be, I mean, external data, so that at the end we should be able to integrate all this information, as already I mentioned, in a common knowledge database in some sense. So this is one important level that is based on the data model, and for that we are following existing, I would say, standards, if you like, that are already being considered in the community, basically based on an NGSI-LD in that sense, that will help us not only for our internal interoperability with the systems, but also to allow the interoperability with external systems. That I think that is the other important point, no? To be able to interact, to exchange information, to exchange possible models with other platforms that can be developed in other projects. No? So to have the vertical, but also the horizontal interoperability issue. And finally, is the connection to the external services I already mentioned. For example, things like follow standards also on the connection with the grid. Specifically now with community energy ideas that is being pushed by the Commission, and that will be clearly quite important to be able to allow this interoperability using also the kind of standards that already are available for these solutions.
Thanks, Antonio. Caterina, as you mentioned, your project is a bit different because you are addressing the construction phase. Is there something specific on your side on interoperability?
Thank you, Karin. Interoperability is one of the key objectives of Cogito as well. In our consortium, we also have the Polytechnic University of Madrid that are expert in this domain. And although the concept is a bit different from the other projects, I have heard by other projects that they are also focusing on the BIM modeling, the building information modeling, actually. So in this respect, in Cogito, we are planning, and I saw that other projects do actually, to use IFC, which is an ISO standard. It is a well-structured, well-defined standard, and provides a platform which is neutral. It has an open file format. It is not controlled by a specific vendor. So by adapting IFC and further extending it in order to support Cogito solution, we think that we can contribute to enhance interoperability in construction phase, but this can further be used also in other projects dealing with energy efficiency, providing energy savings, and so on.
Many thanks, Caterina. I now have a question for Carmina, for eTeacher. What are currently the main challenges to enhance behavioral change regarding the energy use in buildings, and how have you tackled this in eTeacher?
Okay, thank you, Karin. Well, there are many challenges within the project, but I will summarize them in two groups, like technical challenges and also the social challenges. For the technical part, the challenges that I mentioned during my presentation, there are many types of buildings. Also the interoperability of the different systems, because we have different tools integrated into the eTeacher app. That will also be a challenge. So in order to tackle all these issues from the beginning, we need to have a clear plan. We have developed a methodology to have all the steps as general as possible for all the different buildings. So we have do the characterization of the buildings to understand how they work in order to implement the monitoring system. And then we also have the data quality issue, which I mentioned before also. And we have 3 different countries where we have the pilot buildings. So we have UK database, and also the Spanish database, and also the Romanian database. And we integrate all that into our centralized database. So that will be, in the future, we will do that in a different way. Having a centralized database and everything centralized will decrease the efforts for the maintenance and also the transmission of data and the interconnections. So that will be one of the lessons learned. And also, as I mentioned quickly, also the other challenge is the social part. So I think we need to engage with the users from the very beginning. And in eTeacher, we have a lot of workshops to gather users' feedback and to understand their motivations and what they were expecting and what they need from the tool in order to design the tool that is appropriate for all of them. So that would be the summary.
Okay, many thanks, Carmina. Well, I think that we have now reached the end of our webinar. Sorry if we had less time than expected for the questions. Please let me thank again our panelists and many thanks to our participants. As mentioned at the start of the webinar, the recording and the whole presentation will be available on the BuildUp website, so please visit it. And if you haven't done so already, please register to our Smart Building Innovation Community on SmartBid4EU website. And let me now wish you a great afternoon and thanks again for your participation. Bye-bye.
Bye.
Thank you.
Bye. Thanks again.
Bye. Thank you for the
Bye.
organization.
Thank you. Thank you.
Bye bye.
Thank you. Bye.
Bye bye.